All right, everyone, we are at time, so thank you for joining us. Introductions. I am Jess Schultz. I am a program manager at Microsoft building Azure Arc-enabled data services. And my better half for the next 50 minutes is...
Ben Weisman. I use what Jess and her team are building for us. So Microsoft Data Platform MVP, you can find my Twitter info up here. Ping me there if you have any questions after that, or better ask Jess because she will have the better answer. But anyways, we're going to do this super demo heavy.
Yes.
But before we get into the demos, we're doing like a very brief round of intros just to clarify some product names and all, because some of that is a bit confusing. If you've been to previous sessions on Arc or Kubernetes this week, some of that might be repetitive. I promise we will not do more like 45 minutes of slides. So we're keeping this super brief.
Demo.
Yes. So Azure Arc. As we've, you may even have seen this slide in the keynote this morning. We're living in a very hybrid data world, and this is what Azure Arc does. What Azure Arc does is it bridges the gap between your on-prem environment, Azure, other private and other public clouds. There's tons of offerings. I'm actually doing a session tomorrow called Almost All About Azure Arc in 20 minutes, where I'm covering all the other things. For you, just important, Arc, it's not a single product. It's an overarching, see what I did there, product or product group name for everything that is kind of hybrid, stuff that Azure brings to you or that you bring to Azure. The other thing that I want to clarify real quick, you may have heard that Kubernetes thing a couple of times. And drink, exactly. Thank you, Matt. For some of you, like Anthony, he even wrote a book on it. There might be, I know what Kubernetes is. For some others, that's still like this black boxy. So, bare metal. We all know that. We've had that for decades. So you take a dedicated machine, like actual metal, and install some application, operating system, and so on it. Virtualization, you probably also know that. So we started doing that, let's say, in the 90s, maybe, when like Hyper-V and ESX first, then Hyper-V and all the other virtualization platforms came. Basically, virtualization means in your bare metal machine, you just install multiple other computers with a ton of redundancy because they also have their own operating system, they have their own network, they have their own disk, which also means you have to maintain all these different systems.
You have to patch every operating system and
run 3 SQL servers in 3 different VMs. You're patching 3 Windows machines and 3 SQL servers. Yeah, I can automate all that with PowerShell. You still have to take care to actually happen.
Do it.
Enter containers. If you're using containers, a container is based on an image. Think of an image like an ISO file. Again, there's more to it, but we're keeping it brief. You download this image, and everything we're going to see with Arc MI is based on these container images. So you pull that image from an image registry, which is nothing else than a web server, or you can build your own images, and you just spin up these images into memory. With the example of SQL Server, you download the SQL Server image once, and if you want to run 3 SQL servers, you just spin that image up into memory 3 times. If you want to update, you just download the updated image and spin it up into memory again. Problem with containers, they don't talk to each other very well. Container orchestration. Enter Kubernetes. Drink. In Kubernetes, we use these containers, group them into so-called pods. So a pod is a concatenation of one or multiple containers that form an actual working application. So a pod may just have one container, or multiples, like you may have a front end and a back end in the same pod, for example. What Kubernetes also does is make these work together. So you have typically a control plane and worker nodes. A plane or a node is a physical or virtual machine. And everything that Kubernetes does is it makes sure that these containers, that these pods, run somewhere in your cluster. So you download your image, tell your control plane, I want this image or this pod, this container to run 1 instance, 5 instances, 10 instances, and the control plane will make sure that that happens. The cluster will usually be separated from your storage, meaning whenever one of your pods dies, meaning it disappears from memory, a new instance of that pod gets spun up, but it attaches to the same storage as the previous pod. So technically, when you restart a SQL pod, first of all, you don't restart a pod, you kill a pod and create a new one. You point it to the old storage. From a user perspective, you get the same database, you get the same data.
And that's a big deal for, app developers are really leaning towards Kubernetes, but most apps don't need that kind of persisted volume. They're a little bit more stateless, but we are able to make, stateful persisted storage
Correct.
here for our data, which is really necessary for applications.
It would be a very sad story if every single time a pod needs to restart or a new pod needs to be created, it might be due an upgrade or an outage of a node if all your data was gone. Anthony and I are actually doing a panel on Kubernetes today at 5:10 in room 6. We're going to go more in depth on Kubernetes. So for Kubernetes, what you really need to know for today, Kubernetes is organized in something called namespaces. Think of a namespace like a named instance in SQL Server. Single level folder structure. Within that namespace, you will have something called a persistent volume claim or multiple, which is just Kubernetes' way of abstracting, I want to access this kind of storage. So it's pointing to some physical storage. You have your application or a deployment, which is accessing that claim, so it's accessing that storage, and all that is exposed through a so-called service. So you have a persistent endpoint, meaning if your managed instance moves from one node to another, to the outside, it will still have the same IP address, same port, etc. So from a user perspective, your pod may move around your cluster constantly. You will never notice this. That's what you need to know about Kubernetes. All right. Azure Arc-enabled data services based on Kubernetes. If you've been here for the previous session, you have seen the Azure CLI kubectl, is it?
Kubectl.
I don't know how it comes up with these things. kubectl, Azure Data Studio, known tools, or the Azure portal. So you will have known tools that you're already using to deploy and manage your Arc-enabled data services. On top of your Kubernetes cluster, you're deploying an Azure Arc Data Controller, which is the control plane of your Arc-enabled data services deployment. So it doesn't do much by itself, and you still need it. It is...
I like to think of it as what I call the brains of the operation. It's where APIs live that you talk to. It's what manages the logs, the monitoring, the deployment. So it's not something you actually connect to. It's not the SQL instance itself, but it is the base brain that everything communicates through.
Cool. Again, Arc Data Controller, we're talking to that using the exact same tools that you already know. We're going to be deploying an Azure Arc SQL MI later. If you've deployed an Azure SQL MI that is not Arc-based before, using the command line, the command will look very, very similar to you. So there's lots of similarity to either Kubernetes native tools or Azure native tools. So Arc-enabled data services are both Kubernetes and Azure native. On top of that data controller, in that same Kubernetes namespace, you can then deploy your Arc-enabled SQL managed instance or your Arc-enabled PostgreSQL hyperscale. Can you just have one of each?
No, you can mix and match. So you can have multiple SQL MIs, you could have multiple Postgres servers, or you can even run one or two of each if you'd like.
So all that is happening here. We will focus in this session pretty much purely on the managed instance part, which is also, whenever you make a poll in the room and make people raise who's using Azure SQL, who's using SQL Server, basically all the hands go up. Who's using Postgres? Less hands go up, at least for now. It may change. You can automate all that, because since everything in Kubernetes and everything therefore also in Arc, and Azure is infrastructure as code, you can automate that using Git merges. So you can basically have a build pipeline that will automatically always keep redeploying your entire environment. There's built-in monitoring tools, Grafana and Kibana. Now I have Bob Watt singing again in my head. Grafana. So you get the built-in monitoring, but you also got the direction into Azure. Yes, direct and indirect. For those that haven't been in the previous session, you want to elaborate on the difference?
Let me touch a little bit on that. So in Azure SQL Managed Instance, clearly that resource lives in Azure. With Arc-enabled SQL Managed Instance, we're containerizing it and giving it to you to run outside of Azure. So it's an Azure resource living outside of Azure. You might be under the impression that thus where this lives must have a direct connection to Azure at all times. We do have a mode for that called directly connected mode. Directly connected mode is great because it gives you instant, always-on visibility into your resource in the portal, so you can see your billing and your usage and your metrics and your logs at all times. But we also realize that not every server can be public internet facing. We realize that there are factories and retail locations that may not have internet connectivity or bad internet connectivity. So we also enable what we call an indirectly connected scenario. And here you still bring the container onto your infrastructure. You still have all of the same PaaS-like capabilities, but you don't have to have that constant connection to Azure. Rather, you simply export and upload your metrics and usage on a regular basis and forward it to Azure.
So basically all my data is staying on my premises or wherever I deployed. It's just the metadata and the logs that end up in the Azure.
Correct. You have full control over the data within the infrastructure of your choice that continues to live outside of Azure, and we simply send up some metadata.
Cool. If you have all that data sitting up in Azure, it kind of becomes an Azure resource. Because it's still running on your own infrastructure, but all these log files, all these metrics, they now sit in Azure, so you can use Azure native tools like Azure Monitor, Azure Log Analytics to make more out of that. You can also take a look at the Azure billing portal to see how much this is actually costing you. That's probably the sad part about it. It's not fun.
So on the billing portion, just one quick note. In the traditional SQL Server model, you would pay your licensing per year, renew on a regular basis. In Azure, you're paying per vCore, per hour, so you only pay for what you use. The Arc-enabled SQL Managed Instance follows the Azure model. So again, per vCore, per hour, you're only paying for what you use.
So basically, if I have that one server that is currently running a perpetual enterprise edition, but I only need it like once a month, that might even be a use case to just get an MI, just pay for that single day or even single hour?
Absolutely could. Or if you have a system that you're using that is, maybe you're a retail store and you know that your busy period is September through December, and so you've scaled your entire server to meet those demands, you could use Arc on premises to scale it down during the less busy times and only pay for that smaller amount and then scale up when needed.
Cool. All right. That's it for the slides. It's demo time.
Who wants to see some demos? Yay!
All right, so let me walk you real quick through the environment that we've set up for this. In theory, you can run this on any CNCF Kubernetes, and what that means, you can run it on any Kubernetes. You could even run it on Azure Kubernetes services, but then there's always someone in the room that rightfully asks the question, yeah, but if I'm running it in Azure, why would I even use Arc? Why am I not just using an MI? Great question. That's why what we did is we're running a Hyper-V server here, and on top of that Hyper-V server, we've just deployed a couple of traditional VMs. They're all running Ubuntu Linux 2004, and I've actually deployed two different Kubernetes clusters in here as part of the demo. So we have two clusters here, a big and a small cluster. If we take a look at If we take a look at the small cluster, you can see it has one master node or one control plane node and two smaller worker nodes. And if we look at the bigger cluster, you will see it has 3 work. So the number of worker nodes and the size of these nodes basically just determines how much power, how much performance do you have. So if you're deploying like 3 virtual machines as your worker nodes, and these 3 virtual machines all have 8 CPU cores, that is the maximum you can have for a managed instance as well, because you cannot scale across multiple worker nodes, meaning if you have 8 CPU cores, you will not have an MI that can use more than 8 CPU.
So if you do plan to scale up and down, make sure that your core cluster, that Kubernetes resource, has been sized to what you want as an upper limit so that you can scale down, scale up and down within that.
The other thing we did in advance, because it would take too... Basically, whenever you deploy something in Kubernetes and that image isn't there yet, it will automatically pull it for you as long as it can do that, meaning as long as it's not coming from some private repository. All this is coming from the public Microsoft repository. But since we're going to be looking at the current and the previous version, because we're also going to be looking at upgrades,
Yes.
That's more than 40 gigabytes, or since I actually also downloaded the previous version, it's like 56 gigabytes of containers per worker node. They need to be on every single worker node, meaning if we deploy something and that image isn't there yet, it needs to download it first, meaning we would need to wait potentially for 56 gigabytes to download over the course of this session.
We don't want to do that
It
over
might go
conference
so-so.
Wi-Fi.
I have mixed experience using that approach. So that is basically what we've done. All right. We were going to be using indirect mode, and as mentioned, with indirect mode, we're not even necessarily talking to the Azure portal constantly. Still, I will log into my Azure subscription, and in that Azure subscription, I'm going to set a couple of variables here, name of my resource group, region, and so, and also a super secret password that we will be using once we're deploying our instances later. I will create a resource group in Azure. Again, that resource group will have the only and single purpose of holding my metadata later. All the stuff that we're creating, all the stuff that we're deploying will happen here on my local not local, but on my Hyper-V-based VMs. None of my actual data will touch the Azure portal.
But the whole point of Arc, this entire Arc family of products, whether that's Arc-enabled servers or the SQL Server extension on Arc-enabled servers and Arc-managed instance, is to use the Azure portal as one single pane of glass to see your resources that exist in Azure, that exist on premises, that exist in other clouds, and allow you to manage them all the same way, deploy them the same way. So we hold the metadata, as Ben said, but the data still exists in your infrastructure.
Correct. All right. If we want to deploy an Arc managed instance, we're going to need some kind of a brain first. Which component was that again?
The data controller, Ben.
Who said it?
Yes.
Anthony wrote a book. After this, pick up a copy. It's yours. What I'm going to do is I'm going to kick off a command line process here, and I'm not going to tell you what it does for now, because I'm going to tell you what it does briefly. It's deploying a data controller in indirect mode, and while this is happening, since this takes a few minutes, Jess will actually show you how to deploy a data controller in direct mode through the portal.
So one thing I want to stress about this is when you're using Azure, you have multiple ways to create and manage your resources. You can view things in the portal and use that experience. But I come from a background as a DBA. After I learned how things worked, I turned to scripting and automation because that makes my life easier. We have followed the same process here. So when you're using Azure, you can use the AZ CLI. We also have the AZ Arc data extension for CLI, so you can script everything. And because this runs on Kubernetes, you can do everything using kubectl.
kubectl?
kubectl.
I'm confused. What is happening?
But let's just take a brief look through the portal to see what this experience would be like for creating a directly connected data controller so you understand some of the concepts. Of course, you do have to choose which resource group am I using?
I'll do the Arc demo RG.
Arc data RG? Okay. So you have to pick your resource group, again, where to group these resources and manage them. We would create a data controller name, and I am not using my keyboard, so I'm going to be confused. And here is a concept to understand about this directly connected mode. When you deploy in Azure, you choose a location. This is your Azure region, like East US or West Europe. In Arc-enabled, you are deploying to a custom location. This is your location. What it does is it maps to that Kubernetes namespace, which we talked about earlier. So we want to go ahead and create ArcDS. Nope, there's no Kubernetes cluster register. Have we in Arc-enabled?
No, we have to
Yeah, okay. You do pick your Kubernetes configuration template. We support out of the box multiple common Kubernetes platforms, which all have their different storage configurations, what they call their storage classes. We've made it very easy for you to pick things like AKS-HCI, or OpenShift if you're running on Red Hat OpenShift, or kubeadm if you're running locally. Then you pick your infrastructure. Let me use default storage. So default, you also have the choice to pick node port or load balancer. These are essentially Kubernetes concepts. Node port gives you a static IP. Most people choose to use a third-party load balancer that they use for other applications and such, and then use node port. If you don't have a third-party load balancer, we can designate that for you. And then you would enter your metrics and logs credentials. So this is what would log you into the Grafana and Kibana instances for those items. And then you go ahead and on your addition, you would add in any tags you want and review and create. So that's the portal experience. Let's see what that looks like after it's been created in CLI.
Oh, and by the way, the cool thing here is we're deploying through the portal. This means in the portal, basically an ARM template is being generated and executed. You could use such an ARM template from your local, it will still deploy something on our local environment. So,
but it talks to that ARM API.
Right. So I was on a podcast with Anthony about a year ago, and we were asked what is Arc, and he described it as Arc basically extends ARM to wherever you have stuff, and I think to this date this is pretty much the most accurate definition of that. So let's see. Did it finish? It did, because usually, if we were just looking at this, it would probably take forever. What did I run here? I ran an AZ CLI command, AZ ArcData DC data controller create, and then I was passing all that extra information that you've just seen from Jess in the portal. What's our connectivity mode? Is it indirect? Is it direct? What's the name of my controller? What's my Kubernetes namespace? Which subscription am I going to use? Jess did not have, well, yeah, you actually had to look for the subscription first.
Correct, the subscription was pre-selected.
What's my resource group? What's my region? What kind of storage am I using? All these same things. And this deployed my data controller for me. What I can do is I can go to Azure Data. Who's using Azure Data Studio?
Excellent.
Okay. For those of you that do not, please do. It's not just for Azure, so if you... Thank you again. Even if you're still completely on-prem, check out Azure Data Studio. And even if you're not even using SQL Server, because Azure Data Studio has extension for Postgres, for all kinds of relational and unrelational database systems.
Yeah. And the best part about Azure Data Studio is that it runs on Windows, it runs on Linux, it runs on Mac. So you don't, like if you're a Mac user, you don't have to create like a Windows shell to run SSMS, it's just native there.
Correct. So ADS, Azure Data Studio, also gives you a wizard-driven experience of what we just did. So, and I'm going to show you that later with a managed instance. So every single component in an Arc environment, in an Arc data environment, it can be driven through a wizard in ADS. Technically, all that wizard does in the background is it will trigger the Azure CLI again.
Calls the same CLI commands that we just ran.
Still, I think it is a great way to learn and understand these. So if you say, hey, this is going to be my first Azure CLI-driven deployment of a data controller, I've never done that, you can go through the docs and everything, or you just go through the wizard and then copy and paste that command and learn it that way.
I find this similar to when I was first a DBA and I used Management Studio and would, right-click on a database and say backup and go through the GUI and then script it out and learn it. Similar experience here.
So since we have already deployed our data controller, I can add it here in Azure Data Studio. If you don't see Arc in your Azure Data Studio, it's an extension. It's called Azure Arc. You just go to the extension marketplace, download it. It's fairly small, and it brings all that. And it will again confirm all that we've just defined when we've deployed it. So we're going to have a cluster that's called ArcDC Cube ADM. It's in EastUS. It's a data controller. It's in the Arc namespace. This is my subscription. This is my resource group. It's in indirect mode. Basically everything that we've just seen on the command line. I could even open it here in the Azure portal, but spoiler alert, we wouldn't see anything yet. We're in indirect mode, meaning we haven't talked to Azure yet. We will only talk to Azure once we first submit our metrics and log files. What this did is, in Kubernetes, it created a namespace for us called Arc. It created a couple of pods for us. So remember, containers being grouped into pods. We see, let me just zoom in on that a little bit as well. We have our bootstrapper, which is one pod that consists of one container. One of one is ready. The others have two, respectively, three different containers in them. And that's different containers. So that's not some kind of scaling, but that's really different applications that are being bundled here into these pods. And that's all up and running. And it usually takes, if the images have been downloaded before, a good 3-4 minutes to deploy a data controller. So not horribly wrong. And we can also use the same CLI to check out our status. So if we do AZ Arc Data DC status show, it will tell us, okay, I'm ready, cool. And we could also check the logs for that controller using kubectl. Whoops, hang on, there we go. And we'll give you a couple of error messages in the beginning because all these pods and all these containers come up trying to talk to each other. One is not ready yet. At some point we'll say, hey, I'm ready. I'm using kubectl. I'm using a native Kubernetes tool, and I could have used also the Azure CLI to get the same result. So again, if you're already using Kubernetes a lot, but not Arc, use the Kubernetes tools. If you already use the Azure CLI a lot, but not Kubernetes, use the Azure CLI, you get the exact same result. We already added it in ADS, and since we are actually here to talk about managed instance, how about we get a managed instance?
Let's do that. That data controller, again, is the brains of the operation, but what my data people are here for is, where's the database? What's the data store? So
Can we say data control is kind of like the bug woody, so you kind of can do without it, but it doesn't do any actual work?
That's really true. You're entirely correct. So what I'm going to do is create two different managed instances so you can see a couple of differences. We have two tiers of service within the Arc managed instance. They are called general purpose and business critical. Now in Azure, these tiers relate to what your type of storage is and what your number and type of CPUs and RAM are. In Arc managed instance, the general purpose tier aligns to the features and hardware limitations of SQL Server Standard Edition, and business critical in Arc aligns to SQL Server's Enterprise Edition feature set. And as we'll see, general purpose relies on Kubernetes underlying pod restart for high availability. Business critical brings in availability groups. So here is, again, using the CLI, we run a SQL, so AZ SQL MI would be in Azure. Here we have AZ SQL MI-Arc to do a create. We're going to pass in a name, the Kubernetes namespace. We tell it what storage class for data and logs. Here we tell it how many CPUs and how much memory we want. We pass in general purpose, and this --dev flag will allow you to run essentially developer edition so that you can test this out without spending any money in Azure. Same rules apply for developer edition, not using production data, not running in production. While that is going, I want to bring up one of my favorite tools. If you are interested in, if you're not overly familiar with Kubernetes, trying to understand the different, like what's a pod, what's a container, where does this live, where does this managed instance pod live in my cluster? There's a free tool called Lens, L-E-N-S, that allows you to connect to a cluster, and you can see within any namespace, here we have Arc, we can go to pods and we can see that we have a bootstrapper container that has, or a bootstrapper pod that has one container. We see our control pod with 2. If we go down to like metrics db-0, we see 2. So I love this tool. It also allows me to go into a control pod, and in this top right corner, click on pod logs, and I have another way of seeing my logs. So I just wanted to show this free tool because I have found this very helpful for managing my Kubernetes clusters.
So what you're saying is, instead of spending months and years on learning all these kubectl commands, I could have just clicked there and be done?
Well, you could have.
Good to know.
All right, so we are currently deploying our namespace. What we're going to get when we deploy general purpose is one additional pod. That pod will have one container that holds the SQL MI instance and a couple of other containers for monitoring and metrics. Let's go. Do you have 2 open? I'll open another one. All right. Again, everything that we've been showing with CTL can be done in Kubernetes, but it is not set. We have not set a new one.
These 4. 31.
Yes. There we go. I wrote this script. You would think that I remember which line every command is on, but I do not.
I've changed the order of the script overnight.
What we are looking at right now with this kubectl command is we're looking at the underlying Kubernetes spec for this, so we can see when it was created. I see my name. I see a lot of information about what the default retention period is, how many replicas I have. Again, that CPU and memory information I passed in, information about my data. So if you're familiar with Kubernetes and editing and applying those things, it's easy to be able to view and edit using Kubernetes native tools. So now my managed instance, general purpose, is ready. If I go back and I look at my pods here, I see MI1-0 and MI1HA0. So we have our managed instance pod with multiple containers in it, and then we have a high availability pod which manages the high availability for our managed instances. Now let's see what the difference is when we create a business critical deployment. Almost exactly the same creation experience. mi-arc create, pass in a name, pass in a namespace. Now, let me stop for just a moment. Who here has had to design and deploy an always-on availability group in SQL Server? Okay.
Who of you enjoyed it?
Okay. Who of you were able to do it in less than 5 minutes? Well, Kendall, always bragging. So one of the huge benefits of this Arc-enabled SQL managed instance is that to create and use an availability group, I simply need to choose my business critical tier and tell it, do I want 2 or 3 replicas? Now, so again, I'm adding in my cores, I'm adding in my memory. Here I'm telling it what size I want my data volume, what size I want my log volume. I'm also able to edit some SQL Server startup configuration items from the CLI, so that's important to note. For example, I could use a default collation. I can enable SQL Server agent. I'm going to go ahead and run that.
Minus use case.
All right. So again, the difference between these two tiers primarily, general purpose has the standard edition set and managed instance has or business critical has the enterprise edition set.
While we're waiting for that, we had a question yesterday that I also get a lot. Since we're now deploying Enterprise Edition, is this like full-baked Enterprise Edition? Or
Guess what? It is.
Oh my God.
So with Azure SQL Managed Instance, we have almost 100% feature parity with on-premises SQL Server. The only limitations are a couple of features that require access to the underlying operating system, so those are a little bit limited. With Arc-enabled SQL Managed Instance, we have nearly 100% feature parity with Azure SQL MI. We are working through a couple of things like transactional replication and log shipping. In Azure, we run on a Windows-based system. In Arc, we are running Linux-based systems. But by the time we go GA with our business critical, we should be able to see some progress on that. So we have all of the same engine features that you can think of. Things like you being able to use query store and extended events, being able to use column store and in-memory OLTP. Any features that we have in Azure SQL MI are in Arc.
Cool. So while this is deploying, let's take a quick look back in Azure Data Studio. If I just refresh my data controller dashboard, so basically the entry page into my data controller, what we see here is we have just deployed our MIGP, which was the first one, which is showing as ready, and we have MIBC, which is showing as creating. So again, takes a couple of minutes. A business critical will take slightly longer because it's more pods. These pods need to be tied together. But again, nobody except for Candle said they were able to deploy an 8 hours on availability group in less than 5 minutes. So this is still super quick.
Yeah.
So, and it's done.
All right, it's done. Let's go ahead and...
So again, we can also use command line to list that, which would also give me my endpoints. So these primary endpoints that we see here, that would be the endpoint that you connect to from any client tool. And we're going to see client tools in the demo as well.
Yes. And now if we go back out to Lens and look at our
Wrong cluster.
hold on, there we go. Haven't used this tool in all of a week. Okay, let's go back, go to Big, go to our overview, make sure we're in the correct namespace, and look at our pod list, and now you'll see we have BC 0, 1, and 2. So we said we wanted 3 replicas, and we have 3 replicas. All right, so let's take a look at a couple common things we can do then. I mentioned you can scale your instances. In a traditional physical SQL Server world, if you need more hardware, you have to get a new server and migrate over. Even in a virtualized world, you have to either increase the amount in your virtual machine and then restart it or move to a new virtual machine. In a Kubernetes world, what we say is update, and we change to a new core limit and request and new memory limit and request, and it is updating our general purpose pod right now. And when that's done, we'll have the new size. Now that we're watching it, of course, it's going to take all of a minute. What else can we do with our...
Some really amazing stuff. Now that we have these SQL instances, we can put data into it. I know.
Why would we need data, Ben?
That is a fair question. But let's just assume we could do a show of hands who puts data in the databases. No. And while this
Does anyone ever get to take data out of their databases?
So what I will just do is I will take a copy of AdventureWorks 2019 and copy it into my GP pod. So I'm using kubectl again, tons of other ways of doing it. And I'm copying it to my MIGP0 pod to the var opt MS SQL data AdventureWorks 2019.back file. I could put it anywhere in this pod. So if I would put it to like TMP or whatever, cool. I'll just put it right into the data directory because I think it's kind of best practice having backups, logs, and data all in the same directory. That's what I hear.
Is it, Ben?
I'm not a DBA, as you can probably tell.
And we do enable you to have separate data volumes for your data files, your log files, and your backups, as is best practice.
So we can see that file in our pod. So what we need to do to actually do something with it, we need to get the endpoint of that instance. So what I would do is kubectl get SQL MI. And I will actually need another variable up here real quick. Unless this is done, then yes, cool.
Oh, while he's setting that up, if you're looking at this and wondering and thinking, I'm never going to remember all of these commands, that's great. You don't have to. We have a GitHub repo that is publicly available that has this script out. You can go ahead and just download this after the session and use it.
So what I did here is I grabbed that endpoint, I saved it into a variable. So I'm now just using SQL CMD. And again, I could use SQL CMD, I can use MS SQL CLI, I can use Azure Data Studio, I can use any SQL client of your choice. You're connecting to just another SQL server for that purpose.
Just another SQL server.
So if I do select name from sys database, you see master tempdb msdb. All right, let's run a super fancy restore command here, which will just restore our AdventureWorks 2019. And once that has completed and we do another select name from sys databases, guess what? We have now restored AdventureWorks 2019. So once it has deployed, it's a SQL server like any other, except for a bunch of extra features like backups and so on. But we're going to get to that if we're rushing a bit. How about we talk about high availability first? There's a bunch of monitoring in ADS. I'm going to skip that for now. We may get, you got all the code, so we may not get to every single demo because we want to show you all as much as possible. But
correct. So as Ben was saying, this is not just the SQL Server engine. Remember, we have taken Azure SQL Managed Instance, not just the database engine, but the entire experience around it, and that's what we're giving to you. So this includes automatic backups. You don't have to set up backup jobs. It includes point-in-time restore, just like you have in Azure. All you need to do is pick a point in time after the database has been restored from SQL Server to the Arc-MI. You pick a point in time, it figures out what backups need to be applied. The upgrades, instead of having to do major version upgrades like you do with SQL Server, instead it is that same constantly updated engine as Azure has, and built-in high availability, as we've shown with the deployment. So for general purpose, you're going to get that one pod, and I keep running into my own mouse wire here. You can see that I have the MIGP pod, and it has the 4 containers. Now, what would happen if that pod was to die? What if it would be deleted? Well, the best part is that Kubernetes simply rebuilds it. Remember, your storage is outside of that pod. It is in its own separate volume. So it simply recreates the container and points it to the same storage volume. So that is incredibly useful. And again, all built in, nothing that you have to set up. We're now at 2 of our 4 ready. So business critical, again, we have an availability group built in. You have your primary endpoint to connect to for your read-write workloads. You also have your secondary endpoint that you can connect to. Now, what we want to do in our business critical managed instance here is determine which of our pods is the primary. We've written a great piece for this, and I can see that primary is MIBC0 with secondaries of 1 and 2. So what would happen if I deleted MIBC0? Let's find out. Well, you'll see that BC0 is still pending. What has happened? Has it failed over just like a traditional managed instance would? Yes, it has, and now BC0 is a secondary and BC1 has become our primary. And your apps would connect to that load balancer just like they should.
Cool. As we've shown you before, we have prepared another Kubernetes cluster, and we did that because in that other Kubernetes cluster, we already deployed a data controller and another managed instance. So if we take a closer look at that, what we will see is our Arc data controller in there is already using the current version from March 8th. So we're using a release that's like 2 days old. I think we're pretty brave. But if we take a closer look at our managed instance in there and just to select add version, what we will see is, okay, this is from January 25th, so obviously older than the March release. So what we can do here is we can just say AZ SQL MI Arc upgrade that MI1, and what it will do is, unless we were to define a specific version, which we could also do, so we could go to the February release, which would be the intermediate release between what we're currently at and the March release. It will upgrade automatically to the latest version that our data controller is also at. So it is now upgrading this to the latest version. So if you just do AZ SQL MI Arc upgrade, without providing anything else, you're basically evergreen version. You get the latest SQL MI version here. So while this is happening, what about backup restore? We're not going to demo it because it's going to take too long, but you want to talk slightly about those concepts?
Yes, that is built in. So what we do is a mirror of the Azure service. You have full backups taken weekly, differential backups taken daily, and log backups taken according to how busy your transaction log is, but no more than 5 minutes. And when you need to do a restore, Ben, can you bring up that restore command in our script so that they can see it? That would be great. So you can issue a CLI command that simply says, what point in time do I want to restore to? You don't have to figure out which full backup, differential backup, and transaction logs to use. So that's just a short tour through Arc-enabled SQL managed instance. Exactly. We've got a couple minutes left.
Correct. There is more in this demo. We did not get to everything that was expected, so still, if you download the code from the GitHub repo so you know what to expect, basically the last final piece that we did not see is how you would connect that to the Azure portal. So let me just run through the code super quick.
And for those of you that are here tomorrow, if you're interested in seeing more of this, I'm going to be in the Microsoft booth for the entire morning, and I am more than happy to remote into this environment and give you even more demos and detail as well.
So what we would do is we would create a service account in Azure just so we can automatically talk to the Azure portal or to Azure Monitor in the background without manually logging in every 5 minutes or how often we want to upload our logs. Create a log analytics workspace, and then we run 2 more commands, AZ Arc Data DC export for the metrics and logs. That will create a couple of JSON files that has our metrics and logs. And then we're going to use AZ Arc Data DC upload and upload them. And the second this happens in indirected mode, we have the metrics and logs in there. All our resources show up in Azure.
And then
and we can
Azure knows that it exists now that we've sent the information to the portal, and it is visible as that resource from Azure.
Exactly. And
giving you that one place to view your resources, manage them, and monitor them.
So with that, let's run through the very last slide because we have prepared a bunch of resources for you.
Including a newly released Azure Arc-enabled Data Services Revealed book written by
Anthony.
Ben Weissman and Anthony Nocentino. So please, this is literally fresh off the presses. You can probably see the steam rising from the pages. But also make sure to check out the Pluralsight courses that are referenced, and the Microsoft Learn modules. And what about Jumpstart?
Yes.
That's a series of pre-configured demo and template scripts that you can simply deploy using the Azure ARM API.
So there's just a question online which says, could you show the GitHub URL?
Oh,
The
can
GitHub
we show
URL
the
is up
GitHub?
here, so if you go to bookmark.ws/arcmi-demo, that will take you right to that. And if you download these slides from
That
the
is
conference
the-
website,
Oh, right.
it will also have that link clickable for you. So that takes you right to the GitHub repo that has everything that we have seen today. And yeah, Jumpstart, also super fun way, an easy way to try everything. It's basically a sandbox environment firing up everything for you to try out without messing
Azure.
with your own
Yes.
resources. Not just for Arc Data Services, but for everything that Arc is. And with that, we are
Please.
at time, but if there are any questions, we're happy to take them. Please do provide your feedback.
Did you learn anything today? Yes, okay, excellent. Please let us know that. We want that feedback. And we will be happy to scoot off the stage so our next presenter can get here and be at the back to answer any further questions that you have. Thank you for your time today.